Hi everyone, it's Mrs. Bebo. In this video, we're going to cover lesson 1.3, which is all about tables of proportional relationships. Our main learning targets for today are how do I identify a proportional relationship from a table, and how do I find the constant of proportionality from a table. The only vocabulary for this lesson is constant of proportionality. Remember, two quantities are in a proportional relationship if they have a constant ratio between them. So in the video for understanding proportional relationships, we talked about how they have this ratio that is maintained throughout that table, or those two ratios or rates that we were comparing have, again, the same simplified ratio. So there's that constant ratio. This constant ratio is actually called the constant of proportionality, which we'd like to use the variable k for. It has the same value as the unit rate. And also, this is known as slope, and we use the variable m to represent slope, so that's something you'll see more when you get to pre-algebra and algebra 1. And so in 7th grade, we just call it, again, a fancy name of constant of proportionality, which again, we use the variable k for. And again, this is the same value as the unit rate. So we're going to keep those things in mind that, again, that unit rate, that's going to be our constant of proportionality. So ratios and tables, we're going to take a look at an example just to remind us how these ratios work. So in this problem, it says Miss Spencer orders pizza for her students at the end of the year to celebrate reaching a certain milestone. Each pizza costs $7. Drag the pieces of pepperoni to complete the table for the cost of 1, 2, 3, and 4 pizzas. Well, each pizza costs $7, so I'm going to put this 7 over underneath the 1 because one pizza costs $7. And then 2 pizzas cost $14 because, again, it's now double the price, right? To go up to 14, we're doubling the number of pizzas. 3 pizzas is going to cost us $21. And then last but not least would be the 4 and the 28. So we're going to compare the cost and the number of pizzas for each number of pizzas as a ratio in simplest form. So what we mean by that is if we take a look at like this one here, right? We're going to compare the cost and the number of pizzas. So we're going to write a ratio in that order. So for this, well, it's 7 to 1, right? $7 for each single pizza. If I take a look at the next ratio here, again, if I write the cost first, that's 14 to 2. But if I divide 14 and 2 by 2, I get a simplified ratio of 7 to 1. Then if I take a look at this next ratio, this $21 for 3 pizzas, again, if I simplify that ratio by dividing each part of it by 3, we get the simplified ratio of 7 to 1. And then last but not least, if we take a look at this $28 for 4 pizzas, we get the simplified ratio of 7 to 1 when we divide each part by 4. So all of these have the same simplified ratio, and what we would actually find is this here, this each pizza costs $7 piece, this is actually our K value. And we're going to look at more examples where we actually calculate it out, but again, that unit rate, how much per 1, that is our constant of proportionality. So now let's take a look at this next example. So the following year, Miss Spencer orders pizzas again. In addition to each pizza costing $7, there's now a $2 delivery charge. So no more free delivery. Drag the pieces of pepperoni to complete the table for the cost of 1, 2, 3, and 4 pizzas, including the delivery charge. So for one pizza, it is, again, $7 plus the $2 delivery charge, which means this is actually costing us $9, right? 7 plus 2 is going to be 9. Then we're going to buy 2 pizzas, and this would be $16 because, again, it's going to be 2 times 7 plus the 2 for the delivery charge, which now gives us, again, 16. 3 pizzas, we would figure that out by, again, doing 3 times 7, that's going to be 21, plus the $2 delivery charge is going to make it $23. And then we have our final combination where 4 pizzas would cost us $30. So we're going to do the same thing as last time. We're going to compare the cost and the number of pizzas for each number of pizzas as a ratio in simplified form. So if I take a look at this first one, it's, again, our ratio is 9 to 1, $9 for 1 pizza. If I take a look at the second ratio, we have 16 to 2, and if I simplify this, I end up with a ratio of 8 to 1. And what we find is that without even doing the other ratios here, those two are not the same. So this would not be considered a proportional relationship because we are not getting that constant ratio throughout our table. So when we're going through these examples, we want to make sure that we're getting the same ratio from one set of numbers to the next set of numbers. And if it's not, then we would have to conclude that this isn't proportional. So this would be one that's not proportional. Okay, so ratios and tables, make sure you're paying attention to the order. We're going to simplify them down and then see if it's proportional. And then if it turns out to be proportional, we're going to actually go through and find that constant of proportionality. So again, what does this all mean? I kind of just went through all that, but basically, again, two quantities are proportional if the ratios comparing them are equivalent. So in the table, all of the ratios compared the cost to the number of pizzas are equivalent and have a unit rate of $7 per pizza. So the cost is proportional, just like we were saying. Now, in that second table, those ratios, we just went through two of them, but those were not equivalent. And you can see in this table that they've gone through and they've finished it out, right? They calculated the last two, and they're definitely not equivalent to where we started. So the two quantities in this case are not proportional or non-proportional. So in the table, if those ratios comparing the cost or whatever we're comparing, whatever two quantities we're comparing, if those ratios end up being different, then we have to conclude that it's non-proportional, and you cannot calculate the value of K without it being a proportional relationship. So constant of proportionality only works if the ratio or the ratios are constant and it's actually a proportional relationship. All right, so we're going to take a look at this first example. In this one, we are going to figure out if the amount of water is proportional. So very similar to when we did the video on understanding proportional relationships, it's just now our ratios are given to us in a table. As I warn my students, make sure you're checking every single value in that table because sometimes they do throw one in there that does not follow the same pattern. So we're going to go through and take a look at this where we have an adult elephant drinks about 225 liters of water each day. Again, is that amount of water proportional to the number of days that have passed? So we're going to do that division in that order. So the 225 per day, we're going to look at that same relationship for each of these. So we're going to say, whoops, wrong pen. There we go. 225 to 1. And again, that's already simplified. So 225 liters per day. So we would take a look at our next relationship here and say, all right, now 450 for 2 days. Well, if I divide each of these by 2, we do end up with a ratio of 225 to 1. Then we would do the same thing for the third column. So 675, and again, we're keeping it consistent. We're putting water first, since that's kind of how this problem was worded, right? With the amount of water proportional to number of days, we're going to write our ratio in that same order. So we got our water 2 days. And in this case, again, if I divide each of these by 3, we would end up with 225 to 1. And just because, again, these three are all good so far, I always tell my students, again, make sure you're checking every single value because you just never know. One might not be following that same pattern. So we're going to do 900, and we got to 4. Divide both of those by 4, and we're going to find that it does simplify down to 225 to 1. And so we would say, yes, this is a proportional relationship. So yep, it's proportional because, again, all of those ratios in our table simplify down to the same thing. All right, so now our second example. It says, Katie can read 15 pages of her chapter book in 40 minutes. The table shows the number of pages she reads in 15, 30, and 45 minutes. So is the relationship between the number of pages read and the number of minutes spent reading proportional or non-proportional? So we're going to go through once again and just check each of these. Now, it does tell us we're looking at the number of pages and then the number of minutes. So we're going to do a ratio of 40 to 15, and then we'll do 80 to 30 and simplify that. And then we have one more ratio to check, which is this 120 to 45. So again, keeping that order consistent, we did pages per minute. All right, so if we take a look at this first one, 40 and 15, both of those can be divided by 5. So I'm going to go ahead and do that. And then we would have a ratio of 8 to 3. So 8 pages every 3 minutes. Then if I take a look at that second ratio, each of these numbers are divisible by 10. So if I divide both of those by 10, so far so good, we get a ratio of 8:3. And then for this last one, we can divide both of these by 15. And again, if you didn't see that you could divide both of them by 15, you can always start with something smaller like 5 and then work your way down to, again, that most simplified ratio, which in this case does turn out to be 8:3. So because all of those ratios are the same, that ratio is maintained throughout this table, we can conclude that this is a proportional relationship. So that's going to conclude this portion for this lesson. I'm going to do a part 2 where we actually calculate that constant of proportionality. So make sure you check that out if you need help with finding the value of K. Thanks for watching.